In the last video, we talked about static methods. But just like there are instance variables, like there are both instance variables and instance methods, there are also static variables. And this is where things get a little confusing for some people. So remember that an instance variable is a variable that each instance of a class has a distinct copy of. A static variable is a variable that is shared across all instances. So there are a few there are a few reasons why static variables are nice. And one of them in particular that we'll talk about in this video is, let's say for example, that we want to keep track of how many point objects have ever been created. Okay? So what we can do is create a private int point count value, and then we're going to make it static. Okay? So what we're going to do is inside of the constructor, we're going to say point count plus plus. So by default, we could initialize this to 0. It doesn't matter. Java will auto initialize it to 0. But what this is going to do is every time we call the point constructor, we are going to increment this point count variable by 1. Notice that it's not final either. If it were final, then we'd also have to initialize it, but then we couldn't increment it. Okay? So, yeah. One thing I also like to do is always preface static variables with the class. Now, it doesn't really matter in this context because there's only one variable called point count, but it's just good practice. It's like doing this dot with everything. It's good to always have the class name in addition to the static variable. Okay? So, yeah. So what happens when we do this? Or rather, what would happen if we didn't have this as static? Well, then just like there are copies of x and y with every point, then each point instance would also have its own copy of point count, like its own distinct copy of point count. And obviously that wouldn't make any sense because every time we instantiate a point, it would just go from 0 to 1. Okay? And then it wouldn't be very useful. This static variable, on the other hand, is shared among all point instances. So anytime we do point.point count, it's going to increment this specific one. Okay? So if we go to our paint here, we can say that it kind of looks like this. So point has its x coordinate, y coordinate. So we'll say this is P1, and then we have point, and then its own x and y. Then maybe there's another point, its own x and y, P3. And then somewhere in memory, there's sort of like a little table that stores everything that is about the point class itself. So for example, things that might be here are the static methods, like generate random point might be one of them. Okay, average distance to origin. Okay, I'm not going to write it all out, but you get the point. But in addition to all of that, there are also the static variables. Okay, so we'd have point count, and each instance of point sort of references this table, so to speak, when it needs to. So whenever we create a point, it's going to increment the space or the variable that is defined down here. This one's going to increment the variable down here. This one's going to increment the variable down here. So they don't all get their own copy of point count. Rather, they all share the same variable. Okay? And whenever we change it for one of them, it changes it for all of them respectively. Okay? Because it's a shared variable. Okay? So what about, like, okay, so we've done that. So we generated 3 points. So of course, then the question, I guess, is how do we get that value? Like, how do we see how many point points have been instantiated? Well, we need a static accessor. Okay, so we can just have static int get point count, then return point count. Okay, so again, we make this private because if we didn't make it private, then anyone out here could do something like let's say point count equals 100, and that would be perfectly fine. We make it private to prevent that kind of thing from happening. The only place that should modify point count is the point count constructor itself. And remember that even if we instantiate an empty or an origin point, we're still updating, or we're still calling this constructor because of this, and it's still getting incremented. Okay, so if we want to see how many points have been created, we can simply do that by doing point.getPointCount. And this should say 3. It says 5. Interesting. Where are we creating points from? Let's see. What am I doing here? Ah, that's right. Oh, I'm glad that I caught this. Okay. So, this is interesting. Okay. So, not only did we create these 3 points, but this is where I'm really glad this showed up. I was hoping I could integrate this point, no pun intended, but I didn't know how, and this is a great way. So remember how average distance to origin works. So average distance to origin, if we see, calls p.distance. P.distance creates points. Okay? So for every time, so we pass in a list of 2 points here. So for each one of these, we're going to create a new point at the origin. Okay? So what that means is that we're creating 3 points here, and then we're creating 2 as a side effect inside of this method. Now, it's not a true side effect, really, but it's something that does increment the point variable, or the point count variable. So if we comment this out, then it won't compile, but if we comment that out, then we get total points created is 3. Now, another use for static variables is something called the singleton pattern. So what do I mean by this? Well, consider the following fact. Is there really any reason that we're creating distinct instances of the point class whenever we call distance? So, for example, take this method right here, the one that we just commented out. Suppose we passed to it a huge list of points. Let's say it has 100,000 points. Each one of these is going to run through this stream and this map method, and map is going to create a new point for every single one of those. But they're all the same point. They're all treated the exact same. So there's no need to create a distinct copy of all of these points at the same time, or that are all the same. So what we could do is define a static final point, and we'll call it origin, and then we'll instantiate it to be 0, 0. Now, whenever we want to reference a point that is the origin, we can just call it, or we can just reference it by doing, for example, point.origin. Now note that this is specifically not private, and we do that because even out here, there's no need to create a point at the origin if there's already one defined. Now, what does that mean for this? That means that for the distance method, we can just pass in origin. Okay? Or preferably point.origin. Okay? So the utility of this may not be very clear at first, but and in particular, there's one very important reason why this works, or rather, why this is possible. The reason why we can do this is because point is immutable. Okay? Point cannot change. Like, once we create a point, we cannot change its x and y coordinates. In the next section, we're going to talk about something called mutation, which essentially throws that idea out the window and makes it so that we can mutate objects. Okay? But for now, this is a really good practice to learn about, or a pattern to learn about, and many classes, in fact, do this. So, for example, this isn't quite an example, so I know I just said for example, then contradicted myself, but think about classes with constants defined. So math.pi or math.e or something, or even like when we talked about big integer, we had big integers for 1, 0, 10, and 2. So big integer is an immutable class. So there's no need to create, like, to have distinct copies of an integer, right? Like that all represent the same integer. So remember that objects take up space in memory, and instantiating objects is not a fast operation. I mean, to us it's a fast operation, but under the hood, that performance can really bog a system down. It may not seem like it, but it can. So using this singleton pattern like this is really nice to have. Okay? At least the option to be able to do this is nice to have. And even if you didn't want to expose this to the end user, you could just make it private and then prevent it from being used out here, but at the same time allowing it to be used inside of the class itself.